Hello everyone. So I welcome you to the DSC Mate webinar on deploying ML models using APIs as APIs using FastAPI and Flask. Just confirm me if you are able to hear me and view the screen properly. Just type in the chat box only. Okay. So let's start the session. Firstly, let me introduce myself. So I am Kaustav Gupta, third year IT mate, and I am a machine learning mentor in DSC Mate. So I usually code in Python, JavaScript, and any other language which comes to my project. And I was working as a machine learning writer in Upgrad and Machine Learning Plus. My internship just got uh, finished today, and let's talk about this topic, deploying machine learning models as APIs using Flask and FastAPI. So let us first discuss why we want to deploy our applications. What is the need of deploying the applications? So if you look at this image, this Jupyter notebook in the background, so what you are saying is a Jupyter notebook which most of the data scientists use to perform their daily tasks like training the model and cleaning the data set, fetching the data, and all of the tasks are performed in Jupyter notebooks. But do you think that any recruiter or any end-to-end user would like to run the notebook from the end and then use your model? Suppose you built a machine learning model for salary prediction. You predicted a salary based on number of factors. But do you think that a person will get your notebook and then run the full notebook and then predict the salaries? It's never going to happen. Neither the recruiter nor the end-to-end user will do this. For example, you can take the example of GPT-3. GPT-3 is a language model with 175 billion parameters. It takes months to train the model. I have the access key, but I am not training the GPT-3 on my machine because I simply can't do. I don't have the infrastructure. Neither I can train a huge model like this. So what GPT-3 and OpenAI people have done is train the model, deployed it in a cloud platform, and then provided the access. So we will talk about this later. So the second point I want to mention is taking action based on results. So suppose you built a salary predictor, right? You provided the information and you want a job in data science field as an intern, and these are the various parameters like the experience and the work you have done. So based on that, if you are uh, generating a list of all the companies which offer these experiences, so you can directly match the user with these entries. So these type of actions you cannot take in a Jupyter notebook or a normal Python file. You need to make that model applicable to the users only, making it relevant to the users. Like I said in the starting also, you cannot share this Jupyter notebook with the users and then say them just run the mod, just run all the cells and you will get the result. So that's why we are deploying the models. So that how is the deployment? Now deploying the models. So let's talk about this model. What is this model? So for this webinar, we will be studying the classification model. Like I'm not going to explain the model and the technicalities because I am assuming a bit you know about machine learning stuff. So what I'm going to explain you what is the model we are dealing. So the model is classification model for hip hop and rock. It's popular. Like you will get the data set on Kaggle also. So what the data contain the criteria for the music. Like if you listen to music don't have the title and the artist name and the label. It also has the technicalities like acousticness, danceability, energy, liveliness, tempo, valence. So these are the various factors that decide a music. So we got the data set of these features of music, and then we built a classification model for this. The model was built using decision tree algorithm. So it's a basic algorithm. Suppose consider the case you wanted to attend this session but you had a test, so you will attend it or not. That's a one case. Now if you don't want to attend, what you will do? So that type of classification like you do in your mind is just same as the decision tree algorithm. So that was a brief about what algorithm was used in this model. So we will discuss this. We will use this model as an deployment for Flask and FastAPI. So do you have any questions till this point? Let me know in the chat, or you can unmute yourself also. Just let me know yes, no, so I will proceed further. Okay, cool. So next we will talk about deploying machine learning models using I said APIs. So what the hell is API? So API, you will get this term a lot. API is one of the best use cases of technology, and if you're a Python geek, you must have used a lot of APIs. APIs are around many APIs you can use. So what is an API and why we use it? So suppose you went to a restaurant and you gave a order to the waiter, and the waiter sent that order to the kitchen staff that this XYZ table requires this much food. So what the waiter will do, convey the message from your end to the uh, restaurant staff. So that information carrier waiter is the API here. Suppose the restaurant staff is the server and you are the user. So API is serving the data from the server to your set. So you must be thinking you can do this directly only. You can run the model, you can directly ask the user. But what benefit an API will give you is that suppose a waiter is serving in a restaurant, he's not is not going to only serve you. There are many customers, there are many tables. So the waiter will fetch the data, fetch the food from the restaurant staff and provide all the clients, all the users with the food. So same thing is the API. You can write the API in any language, Ruby, Node, anything, Python. But you can use the API to fetch the data in any language, JavaScript, Python, PHP, any language. You can use that API to get the data. The core purpose of API is to be an intermediate between the server and the clients. So what, like I explained in the layman example, waiters in the restaurant, waiters is getting the food data from the kitchen staff as the server, and then providing all the clients, all the customers in the restaurant as the food items. The main benefit you will get about creating APIs and a model, because you can use that API model to embed in any application. Like you are working as a team and you went to an hackathon, you want to develop a machine learning model case. So one team can work on backend part, creating the API part of the model, and one team can work on making the Android app to use that API created by the backend to fetch the data as a client in the Android app. I will show both the examples, website and Android app, as I've created both of them. So let's talk about how to make this API, how to create this API. So in, like we're talking about in Python, so we will talk about two frameworks, Flask and FastAPI. There is another framework called Django, which is a full-fledged MVP making framework. We will not talk about it as it has a huge scope and it's limited to this webinar. So let's talk about Flask. What is Flask? Flask is micro web framework. You can create, like if you belong to or if you know a little bit about web development, so you must know Node.js and Express. They are used to create the backend of the website. In the same way, Flask and FastAPI are used to create the backend of the websites using Python. So it is similar to Node.js and Express, and almost most of the similarities are same. I have used both, so I can say this. It is used for backend development, and it is popular because it's very easy to use. It's a minimalistic package. You will not find much code in the Flask because it doesn't have any. It doesn't depend on too many libraries. It's only a minimalistic package. But the Flask 2.2 came and it eliminated some of the points. I will discuss that while we will see the code. And that's all about it. You can build web applications, APIs, maybe websites. I build websites also. Many have built websites also. So you can build anything related to web using Flask. So why there was a need of fast API? Why the fast API came? So the main purpose of fast API is to eliminate the speed factor and the easyability of the users. So suppose if I'm building a API and a model using Flask, I will not get features like form validation. Now what I mean by form validation is that when I am providing the parameters to the Flask to make for the API call to predict the results. Like my model requires danceability, energy, like I mentioned in the first half. We want to pass that information to the model so that model can predict and return the results. But suppose like danceability takes a float value and you send a random string. Flask will give the error and break the application. But what fast API will do is that it will lead to form validation. It will check that the value is getting float or not. That's inbuilt. You don't need to create an extra effort for this. But in Flask, you can do the same thing, but it will require a lot of code and lot of validation at your end. So these kind of problems are solved by fast API. Second thing is that it's a modern framework. Modern framework, it just came in the previous years, and it has gained a lot of popularity also. It automatically create docs with GUI. That's the main and the most like feature of from my side. You can create docs for the APIs directly using the fast API. So suppose if I want to know the usage of the endpoints, like most famous API in these times is the COVID API. You all have accessed that API to create some reminders for the notification alerts that the vaccine is available or not. So that documentation is automatically generated using fast API. You cannot do this thing in Flask. Maybe there are some extensions, but as per I know, fast API can do this thing at a at one command. You don't need to explicitly uh, tell any command that create the docs for this. You just access an endpoint slash docs and you will get the all the endpoints API endpoints of the API as the docs. So this type of thing using the fast API uses Swagger and OpenAI specifications for making this uh, GUI interface. I will show you the interface also. It is faster than Flask. Definitely, it is faster than Flask because Fast API relies on UVCon and Flask relies on G Unicorn. So I won't get into the technicals of both, but just try to understand that Fast API can make asynchronous request and Flask cannot do. So I'm just giving you the overview because it's a bit technical to explain and you won't get this at first. And like I said, Flask uses Fast API uses Flask Swagger and OpenAI to do these things. So you have your model. Now let's talk about how to create these codes in Flask or Fast API. So when you have the model ready, like you have done all the pre-processing steps, all the validation, cross validations, and open CV search, you have the final model. So like in this example, I have made a uh, created an example to demonstrate how to prepare, how to pickle the model, how to save the model so that we can use it further in an API. So to do that, you just do a name of the model, and this is the basic Python command to create a file or to access a file. Just the changes here is pickle.dump. Pickle.dump serialize the model, serialized model, and then save it to the disk so that we can access it further. So at this point, if anyone has any doubt, you can tell in the chat section or unmute yourself if you want to ask. Okay, so I'm assuming that everyone got the point. So let's see this in action. Let's see the code, how these things are implemented in real coding. So let me just switch to the VS Code. Just confirm if you are able to view the VS Code or not in the chat box. Okay, cool. So let's talk about how to deploy the machine learning models finally using Flask. So let me zoom in a bit so that it's clearly visible. Okay, so what we will do is import like the usual import statements, import Flask from Flask, and Flask also has predefined request and JSONify. We will talk about this later. Import pickle to unpickle the model. Like I said before, I have already saved the model. This is the model dot pickle file. It is a decision tree file. So first thing is, first we need to initialize a Flask app. Now initializing a Flask app is pretty simple. Just write any name here and equal to Flask name. Okay, so here I'm loading the model. How the model is loaded is pretty simple, like the how we read the files in Python. The only difference is pickle.load, so that the model can be loaded here. Now, like in web development in Node.js or Express, we create routes. So what are routes are basically the endpoints of the website. Suppose you hit the endpoint of Covin API. I don't remember the endpoint of that, but when you hit the endpoint, you get the results. So endpoint is basically the uh, how should I code this? So just understand this. This is, we are creating routes for the Flask. So this only slash route is for the home page. Like first time we are visiting a website, it's a first index page. That's the route for the slash root. So what we will do is create a function for the this route and pass it to this decorator. Now decorators are the functions that, like a decorator is used to register a view of the function. Decorators are used to extend the functionality of the pre-built functions. So the route function is already defined in the Flask app, in the Flask library. So we are just extending that functionality to our custom functions. So we are using, like, I've created an index page function, and I have returned a JSON format for this so that everybody can clearly see the messages. So that's this message returns the this I have made a API for this. So next route we will be creating is the predict. Like as I said, this is the route for the root and this is for the predict. So what predict will do is, if I'm going to the local host slash predict, it will route me to this logic. So what I need to provide in Flask, I need to provide the queries, the argument for the request. Now what is query? So if I go to the Google, like if you go to the Google and uh, go to the endpoint query or q question mark and then equal to, you type the text and you get the results. So that's how the Google queries work. So we need to create similar type of query in our application. So we have created the predict and then query to fetch the data. So the fetching of data is done by getting the argument from the request. I've imported the request from the Flask, and like we can use directly dot get method of the query to uh, get the parameters of our endpoint. So let me run this application and then I will be able to get a better, like, so I'm just activating the environment for this. So let's run Python Flask demo. To see this query more easily, I have installed the Thunder client. You can use Postman also, but Thunder client has released a lot of stress to run the Postman and then do all the processing. Thunder client is way too better for this. So I've already created the Flask query. So like I said, this is the local host where the website, where the server is currently hosted. You can see one, the local host, and this is the predict endpoint where, which we have created here. This is the predict endpoint we have created to get the data. So now we have we are hitting this endpoint and getting all the parameters using this question mark and equal to all the parameters we have to pass, like the accostness equal to this float value. And I have converted what parameters you will get from this, we will it will be in string format. You need to typecast that into float. So float of query dot get accostness. So as like accostness, I have got all the parameters for this. So for this, and like in the query parameters, I can simply write these parameters and type their values. So this is made more easy in Thunder client, but if you go to it will be same, it will be same in Postman, but if you go to the Google Chrome and then access this link, you will not get this type of form. You need to manually type this whole URL, and then you will get the result. So just see that, just see this in action. If I okay, so if I click on send, it will send a query to this Flask demo, this endpoint, and I have got the prediction as rock, because these parameters belong to the rock type of music. So you can change them if it gets anything no. So that's how you can deploy a ML app in Flask. So that's pretty easy, because you can just create the endpoint of this, fetch the parameters from the query, and how you will predict the model. I skipped that part. So as you have loaded the model in model variable using pickle, you can use model.predict function of the sklearn to directly give all the parameters of the model to the predict function and then get the results. Like in my case, it was all these parameters, and in my case, it needed a one-dimensional array, so I had to uh, give it an arrow of array, and then tool is, and then the first result I need to get. So this JSONify function is used to just return this dictionary as in a JSON. The JSON is pretty similar to the dictionaries in Python. It carries a key value pairs, and it's pretty easy to interpret this. As I said in the API part, you can call the API in any language, JavaScript or anything. So it will be easy for the front end and the back end part, backend developers to fetch this data and process it more easily using this JSONify function. They will get the JSON as it is. So as you can see, we can send many requests to this, and if I change, I don't think that the hip hop has a different parameter list. So this was all about Flask. So let me know if anyone has any issues with this or anything to ask in this code or something related to Flask. Or shall I move to the Fast API? Okay, so I'm moving to Fast API. So like I said, in the Flask, you need to create endpoints and route for the API. In the same way, we will create the route for the Fast API. But the only difference here is that we can directly specify the method we want to get, like the get method here and the post method here. But in Flask, you need to pass this explicitly, and here, like the method is equal to post and get. You need to specify this directly. Now the benefit of getting this as a post, I will show you in a bit. So it's almost the same. You have created the Fast API app, you have loaded the model, and just an endpoint of the index so that the front page doesn't return anything wrong, and the predict function. But the main difference here, like I said, is the form validation. You can validate the data you are sending to the API. So Fast API, it depends on Pydantic. Pydantic is a data validation library for the Python. So what Pydantic model does is, if I open up the music class which I've created for this, so the music class inherits from the base model of the Pydantic. Pydantic will automatically verify whether the field provided is of the same type as provided in the model also. So you can skip all of this. This is the uh, additional data I have provided so that I can get the description. You can write the description, and here I will define the costlessness and all the parameters as float, because all of them are float type parameters, and uh, that will be more convenient for us. So the next thing we will do is just directly pass this class, this created class in the data, in a variable called data. So now we can directly access this data as data.dictionary. Like we access the data in Python in the dictionaries key value pairs. We can directly access received as a costlessness, received of danceability. You can directly access this data as key value pairs. That is more easy than this Flask app. Than this Flask app, then getting the query.get method and then getting the our parameter. We can directly get this as dictionaries in Fast API, and the rest is also same, passing the all the parameters to the model dot predict and then to list, and then directly returning this prediction. You can also return this as JSONify. You can also import that data, import that function from Fast API dot prediction and running this as UVCon. So if we make a request to, where is, if we make request to Fast API, so now the Fast API, let me run the Fast API first. So the Fast API is running on localhost 4000 port and directly predict. So now here we are not using the query parameter, we are passing the data to the body itself so that we can use the post method. We are passing is at a JSON and all the parameters. I think this is rock because the temp is 101. So let us send this data. Just notice here you will get a request from this, like this. You got the request from this and the prediction was hip hop. So you can make this thing as good in this Fast API. So what was the benefit of making this Fast API? Like, you were getting the same response in Flask as the prediction, but what was the use of making this Fast API? So let me show you this in browser, like the docs generation. So as you can see here, I have got to the endpoint of 4000. Now if I type /docs, you will get an automatic generated docs for Fast API. It's automatically done. You have seen the code. There was nothing here. There was nothing mentioned in the code to create the docs. It's automatically created by Fast API. So if you go to this post method, you can directly test out this API here also. So if I click try it out and then execute, it will give the results here also. So that's the main benefit of using Fast API over Flask. Flask, you can also create this open API specification using Flask, but it will take a lot of efforts. So instead, you can directly hop to the Fast API. So I've created. So as you have also created a get method for index, you will also get result for this. This is the home page of the API. So in this way, you can create multiple endpoints for an API and then fetch the data for this. So let's see what else we have. So let me show you the applications of this like the real world applications which I've created. So all the code for this, like the fast API demo and the Flask and this music file, is already present in the DSC mate organization repo. You can directly access it here. This is the repo for this. All the code is present and the model file of too. You can test out if you want to try out. So let me show you an application of this. So I have created this. Wait. So what I was talking about, how to make use of this application APIs in your applications. So what you can do is create an Android app, the most basic way. So let me show you an Android app which fetches this data only, like the one I show you uh, in this code. So the Android app is hosted on apptize.io. You can also visit this link to access this app. So if you open up the app, it's in Kiwi ML app. You can search more about it, how to make Python apps using Kiwi, or you can suggest me if you want an tutorial for this. So this is the Android app which I've created for the API. So if you type all the parameters of the music, like you can type here also. Let me put all of the zeros. So basically this app will make a request to our hosted API and then predict the music gen using the data provided in the app. Like when I click predict, you will get the prediction as rock. So this API call was made to the Heroku. So let me show you how what is Heroku and how you can host the any type of API using Heroku. So the Heroku requires you to make a proc file. So the proc file is basically an interface between the app and your Heroku account. So the proc file for Flask usually contains the this keyword web and the G-Unicorn. G-Unicorn is the server which the Heroku supports. If you deploy this Flask app as it is on the Heroku, it will not run because it's not running parallelly on the Heroku. So it cannot make multiple requests at the same time for all the users. So for that, we will using G-Unicorn, and then the name of the file and the name of the app which is created in the uh, Flask app. Like here we created the app. So when you put this proc file and the requirement.txt for the program in a GitHub repo, you can directly connect that GitHub repo to your Heroku account and then simply click on deploy. Like here I have already deployed the application. You can click directly on deploy. So let us check the logs of this so that we can get the result for this. Like this, you see this. We have made a request predict for accostation is 0000. All the values were 0 except tempo, which is 38, and then we got a result here. So if I again click predict, you will get another request, another predict function for this, and you will get the result here. So these kind of things can do with the API. Another example I want to show you is the website. You can also integrate any type of websites using the API. You can do multiple things using API. You can make maybe a desktop application for this. You can create Android apps, websites. You have ample of options for the API. So here also I can type all the parameters for this. I'm randomly selecting the parameters, and as soon as you click predict, you will get a request here that there was a predict request for this. Sorry, this one predict, and all the parameters mentioned which are getting into a model and then getting a prediction. So as you can see, this was a hip hop. So you can just play with your API and then fetch the results to get better and better results. You can do a lot of multiple stuff using APIs and all. So that was all from my side. If you have any questions, anything, any suggestion, or anything you want to ask, please feel free to unmute your mic or maybe share in the chat box.
Good evening. Uh, Actually, I
Good
wanted to
evening.
ask, how should I use API? Could you please just explain it once again?
Like which part?
Using API, I did not get it.
Like the code part or the usage part?
Code part.
Okay, sure. So let's start with the Flask API, part again. So let me just create another endpoint for this tutorial. So closing this, and I'm activating the environment for this so that my dependencies are not mismatched. So the server is up and running. So suppose you want to create an API to return something. So what you will do is instantiate a Flask app. The Flask app can be initialized using the Flask directly, that Flask function, and passing the name. This name is required to run the application directly. This name. So when you use the decorator for this, like I'm creating the route. So suppose I'm creating the route DSC, fine, and in route this route is basically a decorator. Decorators are used to extend the functionalities of the current functions. So if I'm defining a function DSC and returning a simple thing like return suppose the result as hello. This is a dictionary I am returning, but it will be rendered as a JSON by the browsers because the format is almost same. So let's visit this link for the Flask. So close this. When you will hit the endpoint DSC, you will get this result. Hello, like the one which we created here. So the endpoints are basically the points where we can make the connection with the server. You can understand this also. So what we are doing here is that creating the endpoint predict, or you can create any type of endpoint like I created here DSC, and then getting the data from this endpoint. If I give a data here like name is equal to DS, but it will not give any type of result because I have not fetched this data from the endpoint. So for getting this data from the endpoint, you can directly use query is equal to request dot args, and then access that data using the query.get method. So query is the name of the object I'm created. You can create DSC also, any name DSC. Now I will use the get dsc.get, and the parameter I've created is name hello name, and so what is the so let's directly write it here. Mm. So instead of returning, let's return this. As you can see, we have what the parameter contained was returned directly by the website. So that was I was talking about how to create an API and the endpoint.
Okay,
So
fine.
okay. Oh, double quotes. Okay. So any more doubts? Anything you want to ask? Okay, then the Android app part again. So what exactly you want to see? Like the code part or the prediction part? Okay, so you want to see the code for the Android app? Okay, okay. Just wait a second. So the Android app is hosted in this KVML repository of my profile. You can visit that. So the Android app is created using KiwiMD. The file. This is the code for the Android app, but it's not similar to what you saw here or what you make in Tinker or GUI, Tinker or Pygame. That's not the same because to create an Android app using Python, you need to use Kiwi and KiwiMD. So if you have the knowledge of KiwiMD, then only I think you can understand this because it's a different lecture and different part. So the Android app is like the Android app will take more time for this session because it's Android app explanation requires another slides. So what I can show is how the prediction is happening. So if you see this predict function, I'm getting the values for the all the parameters from the app. Like this is the way you get values from the Kiwi apps, and then I'm just making the request self URL request. Like this is the website for the hosted web app, and then using the predict endpoint for this and passing all the parameters for this, and then making the request for this. So the Kiwi MD part is actually not covered in this tutorial. Okay, cool. Any more questions or doubts regarding anything you want to ask in this session or anything? So we'll wait for 2 minutes more.